PAD's router features advanced Fanout capabilities and offers access to a broad range of Fanout pattern options. This allows extreme flexibility when choosing which patterns will best suit your requirements. Before getting started, I examine the default settings for Fanouts and make any necessary changes to those settings. With nothing selected, I right-click and choose Properties. I click on the Fanout tab to examine the default properties that have been set for the design. There are options available that allow me to choose which pins I want to fan out. For this design, I want to fan out all of the pins on the components, so I verify that plain nets, signal nets, and unused nets are all selected. I uncheck all of the multiple connection options so that there will be no sharing of connections by the design objects. In the Fanout length area, I specify a maximum value for the fanouts so that the Fanout patterns remain close to the components. Lastly, I select the SOIC quad tab and choose the desired defaults, in this case, aligned single row, inside, and use grid. I click the OK button to save the changes and apply them as the default settings for all fanouts. One of the first steps in routing the design is to make sure that the decoupling capacitors all have the shortest possible paths to the power planes, so I decide to fan out some of these first. I set the selection filter to components. I then hold down the control key and select a number of decoupling capacitors. I change the fan-out direction to outside. I right-click and select fan-out. Fanouts are created for the selected components. There are many different ways to fan out IC components. For this component, I want to fan out all of the signals towards the inside of the component. With the selection filter still set to components, I select one of the SOICs. For this component, I use the default settings to create a fan-out pattern on the inside of the component. I right-click and choose Fanout. I use the U modeless command to hide the connection lines and make it easier to see the fan-out results. All of the pins are fanned out in single rows on the inside of the component. For the next component, I want to create a similar fan-out pattern, but with all of the signals towards the outside of the component. I select the SOIC. I change the direction to outside. I click OK. Because I've modified the settings while the component is selected, they are saved to the component and do not overwrite the defaults. I right-click and choose Fanout. You are not limited to fanning out individual IC components. Here I want to create a similar fan-out pattern, but for a group of similar components. I select the SOIC and then select 3 additional SOICs. For these components, I change the direction to outside. All of the pins are fanned out in single rows on the outside of each of the components in the group. Now I want to create a slightly more complex fan-out pattern with all of the signals fanning out to both the inside and the outside of the component. I select the SOIC. I change the settings to create a fan-out pattern on both sides of the component. Notice that in this instance, all of the pins are fanned out in single rows on both sides of the component. PAD's router is smart enough to know when to bend the rules. If I attempt to fan out a component and there isn't enough space to place all of the required fanouts, instead of failing the operation, PAD's router looks for the best alternative sites and, when possible, completes the fanouts. I select the SOIC. I'll use the same settings that I applied to the previous component, so I'll change the settings to create a fanout on both sides of the component. Notice that all the pins are fanned out in single rows on the inside and the outside of the component, but where there was not enough room on the outside of the component, a number of the fanouts were placed on the inside.